In this video, I'll show you kind of the steps we're going to use in what I'll call Lab 3. Lab 3 will be about timers. Timers are a way of delaying the action. So we can use a timer to delay like so many seconds, like 10 seconds. And there are a few different types. There's an on delay timer, there's an off delay timer, and then there's even one called on off. So the on delay timer works in that when I energize the timer, it will count up for the amount of time that is set for the timer. And when the timer is done timing, then it'll turn on the output. The off delay timer kind of works in the opposite, where it is always energized, but when you de-energize it, that's when the timer starts timing. And after the timer times out, then it will turn off. So, so we call that an off delay. It'll delay before it turns itself off. And then the on-off timer works in a manner to where the timer actually pauses. If you pause the action, then the timer itself would pause. So the idea of this Lab 3 is for you to just simply get a feel for how these three timers work. Okay, I'm going to use the Micro800 simulator once again, and I'm going to go ahead and show the steps this time of how to use it. Because if you're not familiar, if you haven't used the simulator, I'll show you basically how we start the simulator and how we can actually download it and use it. But first, we're going to use the same logic we already created for Lab 2. So we don't need to worry about recreating the logic here. But what I want to do first is I want to add an on delay timer to delay the start of the pump. So the premise of this will be when I press the start switch, I'm going to delay 10 seconds before I turn on the pump. And that's a pretty common occurrence. We might want to delay the start. Maybe, we might want to push the button and walk away. Give ourselves 10 seconds to get out of the area. Maybe we want to, sound a horn and alert the operators that, hey, in 10 seconds, this thing's going to start, right? So back off. So there's plenty of reasons why we might want to delay the start of something. So to do this, it's going to be pretty simple. I'm offline right now. I have the white background, so that tells me that I'm offline. And up here in the menu bar of this window that we're in, we have a few. We have all these different things. Typically, you start here with favorites, and the favorites had the add a new rung, the branch, the normally open, normally close, and the coils. But we have a bunch of other instructions here that we haven't even begun to explore. So math, compare, move, copy, trig, logical, etc. But we're going to move down to timers and counters. I'm just going to click on that. When I clicked on timers and counters, then a new set of instructions showed up right here. Now it left new rung and a branch, but it took away the normally open, normally closed contacts, etc., and brought these things. So each one of these guys has they're kind of acronyms for something. These are actually the instructions names themselves. So we have counters, and then we have T's for timers. So we're going to work with counters a little bit later, but we're going to work with timers first. So I have a TOF, a TON, and a T on off. So TOF is the off delay, TON is the on delay, and the T on off is the on off delay. So I'm going to click on TON, and when I did that, it dropped it into this first rung. Now the other way I could have done that, if I delete that real quick, is if I would have just held my mouse, my left mouse down on TON, and I could have just dragged it. I could put it wherever I want. For this lab, we're going to put it right behind the stop switch, but of course before the coil. So now we have a TON_1 and TON. Now, the ability to configure this timer is actually very simple. We are going to in this PT, and the P stands for preset, and the T stands for timer. So there's a few pins on this block. We have an N, which of course is whenever this logic here is true, this timer gets energized. All right. And then the Q stands for the output. So that would be the output of the timer, which would basically flow to the next element here on this rung. So we will put whatever logic, whatever logic we want to start the timer will be brought into the N pin. Then we have a PT and an ET. The PT stands again for preset timer, preset value, and the ET will stand for elapsed time. So this actually will show you what is the elapsed time of the timer once the timer starts timing. So in this case, we're going to set it to 10 seconds. So when the timer gets activated, we can watch it actually count up to 10 seconds using this ET box. We can actually use this in the program too. So if we wanted to display the timer somewhere like on a touch screen, we can actually read the value of that as a tag, and we can display that and use it somewhere else in the program. We don't have to program anything in that ET box. It's just going to be a value that timer generates. We do need to set the preset timer because we need to know what is the time, what is the length of time that we're going to make the timer. We have to tell it that. So the premise, I think, is 10 seconds. So we'll make it a 10-second timer. 10 seconds is kind of good because it's not too long for you to have to sit there and wait for it, but it allows you to kind of have some time to watch what's going on. You can set these things to, orders of milliseconds, to seconds, to minutes, to hours. So, we don't want it to be, 3-hour timer for our labs because that will just take forever to watch it run. So we'll set the seconds. So timers for the Micro800, and this would be one of those things too that, each PLC manufacturer does timers in a little bit different way. They all work in the same manner, but they kind of, do this part of it just slightly different. So for the Micro820, the syntax that you actually will put into here is actually in this upper box. When I clicked in this upper box, it gave me a kind of a pull down. I could put a tag in here. I'm going to put a constant, but to make it a timer constant, I'm going to put a T. Then I'm going to put a hashtag or the pound symbol, depending on how you refer to that. And then I'm going to put the value, 10. But last piece here is I have to put the base. What is the base? So again, I have many options. I could put an S, and that will make it seconds. If I put an M, that will make it 10 minutes. If I put an H, I believe it'll make it be 10 hours. So we have to specify the base. So all I got to do is put an S, and that will make it a 10-second timer. I hit enter. When I hit enter, this box is green, and we have the text is blue, indicating it's a constant, and it just says T hashtag 10S. Okay. And again, this box can stay empty. That's it. That's it. So what's going to happen now is when I press the start switch, this will start timing for 10 seconds. Once the timer is done, the pump will turn on. So let's actually watch this in action. So again, we're going to use the Micro800 simulator. So to actually start the simulator, you're going to come up here to Tools, and you're going to choose Micro800 Simulator. And that will actually open the simulator. Now, back up a second. If you are doing this, and if you are going to use a simulator, you actually, when we created the project, we had to choose the Micro850 simulator as the device. If you created your logic and you used the Micro820 as your device, then you have to kind of go back and make it the Micro850 simulator. Otherwise, it will not work. You can't download to the simulator if you didn't tell it to be the simulator as part of its configuration. Now, this brings up the simulator. It looks like a Micro800 PLC. Two things have to happen here before we can actually download. One, verify the IP address. Mine says 127.0.0.1. Yours may be the same, it may not. But if you hit the pull down, it's important to make sure that it is set to the one that says software loopback interface 1 here. We don't want to be tied to the Ethernet connection or the wireless card. These are my NIC cards that are actually in my laptop. We want to be tied to this software loopback interface. So mine is 127.0.0.1. Yours could be different or it could be the same. And the second step is we have to start. We actually have to start the simulator. So the on-off button right here, it is on it's when it's first powered up, or when we first open up the simulator, it is powered off. So we need to power it on. So it just gives us a warning. So it's only going to run for 10 minutes, which is one of the limitations of the free version of the software. So we know that it's running now because this turned green, and I have a power light on my PLC, and I got some thing blinking here, and I actually do have my run light on because I had a program in the simulator already. Okay, so we got this set. So now it's time to download. So just to show you that when I came back to my Micro800 kind of simulator page, I had a connect button here, but I already had my path set. So if you had not, I'm going to clear the path out, and I'm going to hit connect. So I want to show you how to set the path to the simulator if you haven't done it before. So when I hit connect, it pulls up this RSLinks kind of tree, and you see I have a bunch of options here, but one of the options is Ethernet, emulate Ethernet, and I'm going to kind of just expand the triangle there, and now it shows 127.0.0.1, and it says it's a 2080 LC50, and it's a Micro800. That happens to match what I set it to on the emulator before I started it. I should note that once I started the simulator, I cannot go back and change this IP address. So if you didn't set this right, you have to stop the simulator. You might have to actually power down completely, bring it back up, and then you can change your IP address. So I'm going to choose that as my path. I'm going to hit OK. So at the moment, it is actually connecting to the simulator, and it will pop up a window in a second and ask me, do I want to download? Do you want to download the current project? I'm going to say yes. It's going to probably prompt me one more time in just a moment. Yep, do you want to download? I'm going to say yes. Notice that down here, there's a little a running scroll of what's going on. If there's any kind of errors or faults or syntax errors, I'll get that right. So 1 succeeded, 0 failed. So any errors would pop up down here in this output window, they call it. And then the next pop-up says, hey, download is complete. Do you want to change it back to remote run state? And I'm going to say yes, because that will now put it back into run mode. And it just says you can only run for 10 minutes, basically, and that's fine. That's plenty of time for us to do what we need to do. So I'll pull the simulator back up. You'll see that I am powered and I am running. And here's the logic now. So the logic is so I am connected. Again, because the background is now yellow, that indicates that I'm actually connected. It does say that I'm connected here, so that way we know that we are connected to the controller. You can see that also my stop switch is showing as red. You can see that this is in red too. So this is the elapsed time, which will show in red. And the fact that it's red means that it's a live number, and it's going to actually update on the screen, with live data. So let's test out our circuit, right? So again, when I press the start switch, I'm going to delay 10 seconds before I turn the pump on. Now in this case, I'm going to start to push this. I'm going to select the start switch and keep it on. So I'm going to show you why here in a second. So I activate the start switch. That brought power to the timer. The timer is now counting. So you see we're at 5, 6, 7, 8, 9, 10. And then after 10 seconds, that came on. And of course, when that energized, so did my pump running late. Okay. Now I'm going to turn that off. So if I turn off the input, I still keep the timer up and the output on because I have my latch circuit going. And next step is I'm going to hit the stop switch and basically reset the timer. So when I do that, the timer gets reset. Now I want to show you what happens, and I want you to experiment with this too. When I press the start switch, if I stop it, if I turn off the start switch, look what happens. The timer goes back to 0. Okay, so the timer will basically clear. If it doesn't make it all the way to 10 seconds, if something happens to whatever the condition here, if this goes back to false or off, the timer goes back to 0. We have to start the timer all over again. So when I press start again, we're going to start counting 1, 2, 3. Now this will lag slightly, just because of the connection to the device. But there we go. So 10 seconds. Okay. So the exercise here, I'm going to disconnect. The exercise here is to try the 3 different timers and see how they work. So this is the on delay. We will use an off delay. So I can cut this out and I can put the off delay right here in its place. The off delay, it looks exactly the same as the on delay. We will put a T hashtag 10S as well to make it a 10-second timer. But the difference now is that when I press the start switch, the pump will immediately turn on. But when I press the stop switch, it will delay 10 seconds before it turns off. And I'll go ahead and show that to you. Let's go ahead and do that real quick. This will take a moment to reconnect. I have to download again. So we'll choose to download to the controller. We'll take another moment. It'll ask me once again, do you want to download? And I'll say yes. And after the download's done, it will prompt me one more time. Do you want to put it back in run mode? And I'll say yes. It'll run for 10 minutes. So we'll pull up our simulator screen, and in just a moment, it'll pull up the logic. All right. So now we have we're connected again. We have our logic showing. I'm going to hit the start switch. Now, just like I said, the pump turned on immediately. Now, when I press the stop switch, that will take away, this will make this part false. That'll make the timer turn off essentially. And then we will start counting 10 seconds. But this output here will remain on until this timer is done. So let's just watch that in action. So we're counting 4, 5, 6, 7, 8, 9, 10, and there it went. So after 10 seconds, it turned off. Now let's look at the same condition. What happened like we tested before. So I turn on the pump, and what happens now if I press the stop, but then I take my finger back off? So the timer actually paused, or I should say it stopped and it cleared, reset itself. but the output is still on. So the output, just like the on delay timer, resets itself if you change its state midway through. This off delay does the exact same thing. So to turn this pump off, this thing has to stay off for the full 10 seconds. So I'm going to go ahead and put the stop switch back on. Now this statement is false. Timer is not energized. After 10 seconds, the pump turned off. Now I can turn off the stop input. Okay, so that's on delay, that's off delay. And then the third one will be the on off delay. And I'll let you experiment with that. Basically, the on off delay means that if you were to lose your stop switch halfway through the 10 seconds, then the timer actually pauses at that point. And when you turn this on switch back on, it'll continue timing from the point that it left off at. So it retains its value basically. So you don't have to start back again from 0 in the timer. All right, and then once you're finished with this lab, you can disconnect from the simulator. And if you just basically take a screenshot of each time you do this, if you're connected online with the simulator or your real controller, then that'd be great. Show me that connection and just send me the screenshots of the 3 timers.